Welcome to Ida's video channel. In this video, I'll show you how to calculate total water volume from system demand. What it means, I want to know how much volume all the demand takes from, let's say, my tank during the specific period of time. In this case, I have a drawing where I ran the peak flow analysis, and as a source of water, I'm using reservoir, which is an infinite source of water. I will swap it to tank. So I go to swap structure, I will select tank, as you can see here, and I will select this structure. You can do it in a pipe manager as well, or manage and analyze. I'm using compact ribbon. Now, if you use extended ribbon, you can go to manage and analyze. I'm going to pipe manager. Both are the same. I click OK, and then I go to structures. I have no reservoir, but I do have a tank. And then for the tank, I can specify the initial water depth. So at the beginning of the analysis, let's say I have 4 meters of water. The minimum is 0, and the maximum, let's say, is 5. And the tank diameter, I will use 10 meters for now. If you have a bigger network, you will need a bigger tank. You can use 100 meters if you want to. Then I need to go to fire hydrants. And I have 2 options here. If I don't want to use fire hydrants, I can change the demand to 0. And I think that's the quickest for now. So I will select all of them. Then I right click, edit values, demand 0. And the demand pattern will be multiplied by 0 values, which is 0. That's great. Then I go to single house connections. For the single house connections, there's a specific demand defined here, 0.065, but that was for a peak flow analysis. And for the peak flow analysis, I used the peak factor to use the maximum value. But in this case, I want to run the analysis during the day. So which means I can't use a peak factor. I should use a normal total average hour demand. What it means in my case is that I need to divide those values by 4.6 because that was my peak factor. And if I divide 0.065 divided by 4.6 is equal 0.014. So I will select both, then I go to edit value, demand, and it will be 0.014. OK. Then I need to change the demand pattern because this pattern was used for a peak flow analysis. If I go to library, I go to HC, you can see I ran the analysis for 4 hours or 5 time steps, and you can see 0, 1, 1, 1, 1. So I need to use a different pattern. I will import my pattern that I use for the water demand. Let me go to design, water, patterns, water demand, but you can use your pattern or you can modify this pattern. You can find it in this location. If I make this window a bit bigger, you can see the C drive, program data, Autodesk application plugins, Devotech.bundle, contents, and so on. This is for IDAS 2026. If you have a older version, you go to program data. That's the difference. So let me import that. And if I scroll at the bottom, there's a pattern 11. And these are the peak factors that are here. And I can go and rename this pattern. I will call it DimHC demand. And then I go to structures, single house connections. I will select both, edit values, demand pattern, and I will use a HC demand. OK. Then I go to double house connections. The same applies to double house connections. I need to change the direct demand, so I select all of them. Then I right click, I go to edit values, demand 0.028. It's a double of the single house connection value. And I need to change the pattern, edit values, demand pattern, and I will use HC demand. OK. And I'm ready to run the analysis. I will analyze, but don't run a peak flow analysis because that would replace temporarily those demand patterns which I assigned. Then I go to graph. I will sort by type. Then I scroll under the tank and I want to display a pressure. And I don't see anything, so I need to go and check the report. Analysis report. And it says system unbalanced. Execution halted. It might be because there is a very low flow at the time 0. If I go to library, HC pattern 0.2 and I have only house connection. So maybe that is a problem. So if I come here, I see the relative change is 0.09. So one option that I can consider to use in this case is that I can go and change the accuracy to 0.01. Of course, I could try other options. Then I analyze again, normal analysis. Okay. And if I scroll down, everything looks good. And I can see the tank is emptying and there is no issue with the tank. Let me go to graph and we can see the graph for tank. And you can see the starting water elevation is at 4 and we end up at 3.69. Now, what's the volume? So I basically now know the height difference multiplied by tank area and I will get the volume. So let's do it very quickly. I will grab the calculator and I will basically calculate 4 meters minus this value 3.692. 4 meters minus 3.692 equals this height, and this height must be multiplied by area of the tank. And if I go to structures, tanks, then I can go to tank diameter, and the area is pi multiplied by radius to the second power. Radius is 5 meters because the diameter is 10 meters. So let me come back here. So it's this value multiplied by pi multiplied by radius to the second power, which is multiplied by another radius, equals, and this is the total volume. So it's at 24 cubic meters during 24 hours. What if I want to know the volume for a specific period? It is very simple because I can go to graph. I can hover the mouse, let's say between the time 5, I get a elevation 3.969, and then I can deduct value, let's say at time 15, 3.796 multiplied by area, and I get a volume. What if I want to involve a fire hydrant? Let's say I want to open one fire hydrant for 3 hours during this period, because it doesn't happen often that you need to fight the fire for the 24 hours, only for a specific period of time. So let's do that. First of all, I will prepare a pattern that will have a 24 values if I want to run for 24 hours. I can create a new pattern and I can call it FH pattern. Then I will specify number of values 24, but let me see if I can change them. And if I change to 24, all of them are now equal to 1. Oh, actually, I didn't want that. I wanted to open it only for 3 hours. So I will use 0, let's say, and at 12 o'clock, the fire starts for 3 hours and then it stops. Then I go to structures, fire hydrants. I can choose any fire hydrant. I will choose fire hydrant 1, which is closest to the reservoir or tank. Then I will specify demand, 25 liters per second. Demand pattern must be fire hydrant pattern. Then I can run the analysis. Normal analysis, okay. I will check the report, because if the tank is not big enough, I would get an error message here. That tank is closed because I reached the bottom of the tank. All looks good here. Then I go to graph, and here I can see a massive demand during the fire, and I almost ended up at the bottom. You can see there's a 0.254. So again, 4 minus 0.254 multiplied by area, and I get a total volume during 24 hours if I have one fire hydrant opened for 3 hours. And this is how you can calculate the total water volume from the system demand.